Hello everybody and welcome to the Bowtie Teacher. In this video we're going to be looking at the Year 7 December assessment and trying to pin down all the things you need to really do well in this test. Good luck! So as you can see, we've got the list here of all the things you need in order to do well in this test. The first thing that we're going to be looking at is rounding, and the two types of rounding that you need to be able to do: significant figures and decimal places. So on our first page here, we're going to have a series of different numbers and we're going to round them in the different formats. So if we take pi, for example, and we take it to a few decimal places, then we can round that number to a degree of significant figures or decimal places depending on what the question asks us. So what we must bear in mind is that for decimals, this is slightly different to whole numbers when we round them. So let's do pi to 3 significant figures. What we would do is we would start counting from the very first digit that is not 0. So left to right, we got 1, 2, 3, and I put a little line here, just like that. And we look at the next digit after the line to check to see if it's 5 or above. In this case, it's below 5, the 1. So that means that the 4 here, the number in front of this line, remains unchanged. So we would have 3.14. Everything after the line would disappear because the rest of the numbers are decimals. So 3.14 would be pi to 3 significant figures. What we could do is try to round this to another number of significant figures. Let's go for 4. So we're starting from left to right again, 3.141. That's the 4th digit there. We put our line here, and this time the number after the line is a 5. So that's going to change the number in front of the line by increasing it, and it would go up by 1. So the one in front of the line will become a 2 here, and then all of the other numbers remain unchanged. So 3.142 to 4 significant figures. Okay? Everything after the line disappears in a decimal. Let's try to round this to 5 significant figures. Then we have 1, 2, 3, 4, 5. We would put our line here. The number after the line is above 5. It doesn't matter what it is, but it's above 5. So that makes the 5 in front of the line go up to 6, and everything else remains unchanged. Sorry, that's a 4. So 3.1416 to 5 significant figures. Okay? So with decimals, everything after the line disappears here, and that would disappear like that. Try not to add extra zeros or anything like that, because if we have this line here at 5 significant figures, and we then add a 0 to that, even though you might think that that number is exactly the same as the previous one, it has 1, 2, 3, 4, 5, 6 digits here, 6 significant figures, so that would not be correct. Now, if we take pi and we multiply that by, say, 1,000, let's have 3,141.592653.5. And we want to round some whole numbers now. For example, let's round this to 1 significant figure. Then we would put our line here, and everything after the line would become a 0 until we hit that decimal point. So everything after the line becomes zeros. And we look at the line and we see that we have a 1 here, so that's less than 5, so the 3 remains unchanged. So 3141 point, all of that would be rounded to 3,000 to 1 significant figure. And rounded to 1 significant figure is important to us, because if you ever have a question in the exam that has the word estimate in, then you're expected to round every number to 1 significant figure before you do any calculations. So if we had 3.14 times 1.95 divided by 2.13, and we were asked to estimate this, then we would round everything to one significant figure first. If you see the word estimate, then you're going to be rounding to one significant figure. So this rounded to one significant figure would be 3. This one here, we look at the first significant figure, and the second one is a 9, so that would go up to a 2. Everything after the dot would disappear because we're doing whole numbers, and then the denominator would be to one significant figure, that would be a 2. So this would be a 3 as an estimate. You could work this out and it would be slightly different to 3, but as an estimate that would be 3. Let's try this 1000 pi rounded to two significant figures. So we're going to count from left to right, 1, 2. The next digit is a 4, so the one in front remains unchanged, and everything after the line up until the decimal point will become zeros. So you can see that as you add more significant figures, these would start to become more accurate to the real number. 4 significant figures. So here's our 4th significant figure. After that is a 5, so the number in front will go up by 1. Now I just wanted to show you a special case, perhaps when we have 0.7899 and we want to round this to 2 significant figures. As you can see, we have a 0 at the front, so we would not start counting our significant figures until the first digit that isn't 0. So we actually ignore the first 0 and we start counting from the 7. So our line would actually go here. Okay? The number in front will go up by 1. The numbers before that remain unchanged, and because it's a decimal, everything after the line would disappear. Now, if we go to 3 significant figures, then something slightly strange happens. We would start counting from the 7 again, 7, 8, 9, the third one would be here. The number after the line is a 9, so this 9 would go up by 1. Now, that would become a 10, so we would put a 0 there. And we kind of, like when you're doing addition, we carry the 1 to the number in front. If we have a 9, this is a special case, and it rounds up, then the number in front will actually go up by 1 as well. So that 9 becomes a 10, and the 8 becomes a 9, like so. 790. Now, you might think, well, the 0, that doesn't really make any difference, but like I mentioned before, we have to have 3 significant figures in our answer. So if we took away that 0, then we would have 2 significant figures and not 3. Okay. Let's take a look at some decimal places. If we have pi again, and we would like to round this to 3 decimal places. The most common is 1, but we'll try 3 first of all. In this case, it doesn't matter where the decimal point is, we will just start counting from there. So in this case, the decimal point is between the 3 and the 1, so we start counting 1, 2, 3. This is where we would put our line, and the number after the line is a 5, so the number in front will go up by 1. This is a decimal, so everything after the line disappears. 4 decimal places. Let's do that in a different color. 1, 2, 3, 4. That's a 9 there, so the number in front goes up to a 6. Like that. Okay, so it doesn't matter what's in front of the decimal point, we just start counting from the decimal point, which is slightly different to the significant figures. Okay, so what I'm going to do now is to give you a couple of examples, and I'd like you to round them to significant figures or decimal places. So we'll take that number there, and I'd like you to round it to 4 significant figures, 3, 2, and 1. Just pause the video and give that one a try yourself. Okay, I hope you had the chance to do that. For 4 significant figures, we're going to start counting left to right, the first digit that isn't 0, and that is the 1. So 1, 2, 3, 4. There's our line, and let's make that a bit darker. After the line, there's a 3, so that does nothing to the 2. So the 2, the 9, the 4, and the 1 stay the same, and everything after the line becomes a 0. 3 significant figures is going to go there. So the number after the line is a 2, so that doesn't affect the 9. Everything after the line becomes 0. Next one, 2 significant figures is there. The number is a 9, so that's going to make the 4 go to a 5. And everything after that becomes zeros. And 1 significant figure is here. So that's a 4, so the 1 remains unchanged. Everything else is a 0. Hopefully you found those okay. If not, you can try and go to MyMath and search up significant figures and practice some of those yourself. Let's do a decimal place example. So we'll do 3 dp, 2 dp, and 1 dp. Again, pause the video and give that a try. So 3 decimal places, we'll start counting from the decimal place itself. 1, 2, 3. That's a 3, so that does nothing to the 9, the 7, the 4, and the 1. Everything after that line disappears. 2 decimal places is there. The 9 makes a 7 go up to an 8, like so. And then 1 decimal place, that's a 7, so we're going to get the 4 going up to a 5, 1.5. So if you can do your rounding, that will account for a very large proportion of your test. Okay, make sure you can round to 3 significant figures, 1 decimal place, and a few other examples as well. For our next topic, we're multiplying decimals. So when we're multiplying decimals, we need to make sure that we have our decimal point in the right place. So for example, if we have 4.2 times 3.4, and we multiply these two, we can kind of ignore the decimal place initially and put that in the right place at the end. So we'll do this in a normal way. 4 times 2, 4 times 4, leave a 0, and 3 times 2, 3 times 4. So our answer is 8, 12, 4, 1. So we've done our calculation here, and we now need to decide where that decimal place is going to go. So starting from the right side, we count in 1, 2 decimal points like that. So we need to make sure that our answer has 1, 2 decimal points like that. Decimal places, I should say. So when you're doing these multiplying decimals, just make sure that you count in the decimal places at the end and match it with your answer. If you're not sure, we can estimate this as 4 to 1 significant figure times 3. So our answer should be approximately 12. Now it should be slightly more than 12 because we've got 4.2 and we've got 3.4, so it should be slightly above 12, which our answer is. But if we put our decimal place in the wrong position, then we would have 1.428 or maybe 142.8, and those answers are way too far away from 12. If you're using Chinese method, let's just draw this grid here. 4.2 and 3.4. We fill that in. So 4 times 3 would go in there, 12. 3 times 2, we need to make it a two-digit number, so 0, 6. 4 times 2, 0, 8. And 4 times 4, 16. And then we count the diagonals, starting from the bottom right. So we have 8 going this diagonal here, 6, 0, 6 makes 12. Put a 1 there. 2, 1, 1 is 4. And the 1 here in this diagonal is there. So same thing here, we've got 1, 2, so we count 1, 2. Our answer is 14.28. So it's up to you how you actually multiply these together, but make sure your decimal point is in the right place. When we're doing dividing decimals, this is a little bit more tricky because, let's go on a new page here. When we're dividing decimals, let's say we have 85 divided by 0.5, like so. Then what we need to do is we need to try and eliminate these decimal places by multiplying both of our numbers by 10. If we do that, we get 850 divided by 5. And that's a calculation we can do. We can use the bus stop method if we like. And we would do 5s into 8 go 1, remainder 3. 5s into 35 goes 7. 5 into 0 goes 0. So 85 divided by 0.5 is the same as 850 divided by 5. It would also be the same as 8,500 divided by 50. These are all the same thing because we've done the same to the top of the fraction as we've done to the bottom. We've multiplied both top and bottom by 10. So these are equivalent fractions, so we can do this calculation like that. If we had 43 divided by 0.02, then we could times by 10 to get 430 divided by 0.2, and then times by another 10 to get 4,300 divided by 2. So these calculations are much easier to do when we get rid of these decimals. If you would like to practice these, then you simply have to think of some random numbers. 237 divided by 0.04, and check it on your calculator afterwards. So you don't need me to make up these questions for you. You can just put random numbers in your calculator and see if you get the same answer when you multiply this by 2 decimal places would be 100. So 237 100 divided by 4, and just see if it gives you the same answer like that. Now for the last topic, fractions, I'm not 100% sure if this is going to be in this assessment or the next one, so I just thought I'd go through some basic fractions and work with you just in case it comes up. So by far the easiest fractions topic is multiplying, so that's why I put that first. If you have a half times a third, then you just do the top times top, and the two numerators multiplied and the two denominators multiplied to give you 1/6. If you have 4/7 times 3/4, you do top times top and bottom times bottom, and then you always need to make sure that your fraction is simplified. So 4's go into both of these to give you 3/7. A little tip for you to speed things up is if you're looking at your diagonals when you're multiplying fractions, you can actually cross cancel these first before you do your calculation. So 4 and 4 have a common factor of 4, so I'm going to divide those by 4, and then I get 1 times 3 and 7 times 1, which gives me the answer straight away. If I look at the other diagonal, there's no common factors of 7 and 3 apart from 1, so they won't cancel down. But if I have a large number like 28 over 36 times 18 over 14, then I could cross-cancel these before I do my large calculations, which in this test, without a calculator, would be quite difficult. But 18 and 36, you can cancel these down. So 18 goes into 36 twice, and into itself once, and 14 and 28, like that. So on our numerator, we have 2 times 1, and the denominator 2 times 1, so our answer is actually 1, like that. And finally, if we have a large number like 6 times a third, a lot of students will try to multiply top and bottom by the 6, but if you remember, 6 is the same as 6 over 1, so that would only multiply the numerator by 6. So 6 over 1 times 3 is 2. If you have a mixed number, like so, then we change everything into top heavy. So we do that by multiplying the denominator by the big number in front, 4 times 4, and then we add the 3. So 4 times 4 is 16 plus 3 is 19, divided by, and the denominator here stays the same, times by 2.5, so 2 times 2 plus 1 is 5 over this. We can't do any cross cancelling, so 19 times 5 is 95 over 4 times 2 is 8. When we're dividing decimals, then we do a very similar thing to multiplying, apart from we flip the second fraction upside down and turn it into a multiply. So if we have 3/5 divided by a 10th, then we rewrite this as 3/5. That stays the same. The divide turns into a times, and the 1 over 10 turns into 10 over 1. So we've kind of flipped this upside down. Now that we've done that, we can actually cancel these down and then do the normal multiplying from the last slide. So 3 times 2, 6 divided by 1. If we had 4/7 divided by 3/14, we rewrite this as 4 over 7 times and flip, like that. We can cross cancel to get 8 over 3. So dividing fractions is just like multiply, you just have to remember that extra rule of the times and the flip. When we're adding or subtracting, I think these are slightly more tricky because you have to find this common denominator or the same denominator for in order to add these. So 3/4 plus 1/2. We have to make sure we have a 4 or another number that both 4 and 2 go into on the denominator. And most people just multiply these two together to get their common denominator, which is absolutely fine, but if it's not the lowest common multiple, you have to do some cancelling at the end. So the lowest number that 4 and 2 both go into is actually 4. So the 3/4, they stay the same. And the half, well, we would have to multiply that by 2 to get into a quarter. So we do the same to the numerator, multiply that one by 2. So just to clarify, that's times 2 times 2, like that. Now that we have the same common denominator, we can put them both over 4 and do the addition of the numerators. So we have 5 over 4. If the question asks you to turn that into a mixed fraction, then we would say how many 4s go into 5? That's 1, and we have 1 as the remainder. So we keep it over 4 like that. But most of the time we keep it as top heavy. If we were doing subtraction, 5/6 minus 1/4. In this case, we're looking for the lowest common multiple of 6 and 4. So that would be 12. The 6 would multiply by 2. So we'd multiply the 5 by 2 to get 10. And the 4 would times by 3. So we do the same to the numerator, times by 3 to get 3/12. So just like with the addition, we have 12ths on the denominator. 10 minus 3 is 7/12. Okay, I hope that's given you some insight into what you're expected to do for the exam. Most of the exam is focused around rounding and multiplying and dividing decimals, and there could possibly be some fractions in there at the end. But just try to practice all of these skills in order to do well in this December assessment. Good luck, and I wish you well.